What's up everybody, Aditya Mahajan here and welcome back to yet another LeetCode video. The problem today that we'll be looking at is easy problem number 283, also called as move zeros. Now this video is a part of arrays playlist. If you haven't checked it out, check the link in the description for that playlist. Now the problem states that we are given an integer array nums and we need to move all the zeros to the end while maintaining the relative order of the non-zero elements. We need to do it in place without making the copy of that array. So if you take a look at the example that they have given, we are having a vector of 0 1 0 3 1 3 and 12. Now we need to remove all the zeros and put it at the end, and the relative order of all the non-zero elements should remain same, that is 1 3 and 12. Okay, so this is the thing that is expected. Now if we take a look at the simple solution, even though if it is said we need to do it in place, if we take an extra array, the solution is pretty simple. We just check if it is a non-zero or zero. We take non-zero elements into the new vector and then at the end update the zero. So the solution for that goes like this. We are taking a variable to count the number of zeros, and we are creating an extra vector answer, and we are iterating through the nums to check if that element of the ith index, that is, while iterating we are checking if nums of I is not equal to 0. If it is not 0, we are pushing it to answer, and if it is 0, then we are just incrementing the number of zeros and we are just pushing that back again to total number of zeros that were found at the end of the answer. And once that is done, we are updating the initial nums vector. But this is not the solution that is expected. So, but still, this was the first approach that we can do. Now the second approach that we can do is with the help of two pointer, and in that we can just neglect this complete extra space that is required. We can do everything in place. So what we can do is with the two pointer, we can keep one pointer at the start, which would basically point to all the non-zero elements that were found till that point, and then we can take a second pointer to iterate through the complete array, and which would be basically be ahead of that pointer, and check if it is 0 or non-zero. If it is non-zero, we'll be moving it back to the place till the index where it was only non-zero elements. Okay, so let us take a look at the solution, how that is. Okay, so this is the solution for the optimal approach with the two pointer. Now what we are doing is we are creating a variable or a pointer which would basically be the non-zero index at the start. Okay, so I have named it last non-zero found at. Okay, so this is also the variable name in editorial. This was taken from there. Now what we are doing is we are iterating through the complete nums vector, and at the every point of iteration we are checking if that element is non-zero. Now if that element is non-zero, what we are doing is we are just moving that ith index nums of I to the point where non-zero elements were found till the separation where non-zero elements were. And once we move that, we are incrementing that last non-zero found at by 1. Till the end, what we are done with, we have iterated through the complete vector, and the fast pointer or I would be reaching to the end of the nums, and we need to update the zeros now. So what we are doing is we are just iterating again from that last non-zero index found at till the complete vector, and we are just updating with zeros. So that's the solution for the second approach, that is with a two pointer, and the time complexity would be O of n with no extra space. Now this can be done in one more way. It sometimes is an optimization or sometimes it's not, because depending on number of zeros are there, it might differ slightly. So in place of doing like the operations of updating 0 at the last, we can just swap, which would basically help this to save this operation. Okay, so the next approach that we can do is with the help of swapping, and it is very similar to the thing that we did earlier. So we are just taking last non-zero found at index variable or the counter, and we are iterating through the complete vector, and if we are finding non-zero element, then we are just swapping in place of the current element. Okay, so what that would do is it would just move all the zeros towards the end, and we do not need to do the operation at the last. Okay, so that is the third approach. Now I'll be giving you one more final approach, which is like with the help of inbuilt functions that we have. So this is not expected in the interviews, but yeah, it's good to know. So we'll be using two functions, erase from the vector library, and one more is stl remove. Okay, so what remove basically does is it takes one particular number, and from the two pointers, that is For the two, it from the two pointers, it could be a vector, it could be a set, anything. It removes that particular element from that complete set of range that we have given. So from the complete nums vector, what we are doing is we are removing all zeros, and what it will do is it will take it and push all the elements to the start. Now it will return an iterator to the new end with the only elements that we had, without the element that we have, and then that iterator till the end. So erase would basically have two optional operators, that is, if only given one element, it will remove that, or if we give a start and end index, it will remove all those elements. So this being the end of the new elements without zero, and the actual end of the nums will remove all the elements in that, will remove all the element having zeros, and we are just pushing back all the zeros at the end. Okay, so that's the solution for the inbuilt approach. I hope you like the video. If you did not understand anything, comment below. I'll try to respond as soon as possible. If you need more such LeetCode content, subscribe to the channel, and that's all. I'll see you in the next one. Till then, take care and bye bye.